Sodium-ion batteries are bringing an exciting promise for the future of electric cars, and it seems like affordability will be the big differentiator for this technology. Just imagine, today, the price of electric cars is still a barrier for many people. But sodium-ion batteries, which are much cheaper to produce than lithium-ion ones, might change that scenario. And the good part is, this doesn't mean we'll lose out on performance or quality. The Tesla Model 2, for example, one of the most anticipated models, could benefit from this technology and become much more affordable for the general public, especially for those looking for their first electric car. Sodium-ion batteries work in a very similar way to lithium-ion batteries, which are already widely known. Both use the movement of ions to store and release energy, but they differ in the materials and some processes involved. In the case of sodium-ion batteries, the main element is sodium. They have two main electrodes, the anode, negative, and the cathode, positive. During charging, sodium ions move from the cathode to the anode, crossing the electrolyte, and during discharge, they return to the cathode, releasing energy that can be used to power devices, like electric car motors. In recent years, important advances have been made. Materials like iron and manganese compounds for the cathode and hard carbon for the anode have shown great promise. These materials allow sodium ions to move more efficiently, increasing the capacity and lifespan of the batteries. Another key component is the electrolyte, which facilitates the movement of ions between the electrodes. Research has focused on creating liquid and solid electrolytes that support the characteristics of sodium, ensuring stability and safety in different usage conditions. An interesting feature of sodium-ion batteries is their safety. The materials used in them carry a lower risk of overheating or catching fire, which is crucial for large-scale applications like electric vehicles and energy storage systems. With advances in material engineering, the future of sodium-ion batteries looks promising, with significant investments, especially in China by companies like CATL, that could transform the automotive market. With increasingly strict regulations on lithium imports, Tesla may be interested in sodium-ion batteries as a strategic alternative. Besides reducing reliance on lithium, this technology could help the company continue receiving tax credits, keeping vehicle prices more competitive. If Tesla adopts sodium-ion batteries, more affordable models like the Model 2 could be the first to use them. This would pave the way for the production of cheaper vehicles, aligning with Elon Musk's vision of popularizing electric cars. A Model 2 powered by sodium-ion batteries may be closer to becoming a reality than we think. The abundance of sodium causes the price of these batteries to drop dramatically. Lithium, despite being an essential material in current batteries, has a complicated and expensive extraction process. This ends up reflecting in the price of electric cars we see on the market. But with sodium, it's a different story. Since it's more easily found, we can produce batteries at a much lower cost. And this means that electric vehicles, like the highly anticipated Tesla Model 2, could become much more accessible to everyone. In other words, more people could enter this world of electric mobility without having to spend a fortune. Now think about the long-term impact this could have. If the cost of batteries drops, the trend is for electric car prices to follow the same path. This would open up a huge door for more people to adopt this technology. And honestly, it's what the world needs, right? Electric mobility has already shown it's the future, but it's still a bit out of reach for those who don't have a lot of extra money. With the help of these sodium-ion batteries, Tesla and other automakers could transform this reality, bringing cheaper yet efficient models. Sustainability also plays a role in this story. Lithium, as you know, isn't infinite, and its extraction can cause significant negative impacts on the environment. Sodium, on the other hand, being so abundant, has a much smaller impact both in extraction and processing. This aligns sodium-ion batteries not only with the economic aspect, but also with the need to protect the environment. In the end, the idea is to achieve a balance between cutting-edge technology, affordability, and sustainability. A perfect combo, right? And the most curious part is that besides being abundant, sodium is also less toxic and easier to recycle than lithium. This already solves one of the major problems faced by current batteries, which is what to do with them once they reach the end of their lifespan. Sodium, in this sense, offers a simpler path to efficient recycling, which only reinforces the idea that it could be the future of batteries. It's as if we've had a solution all along, but are only now beginning to truly take advantage of it. Another interesting point is that, due to the ease of finding sodium, battery production isn't as dependent on specific regions. In the case of lithium, the largest reserves are located in places like Chile, Argentina, and Bolivia, creating a geopolitical dependency. With sodium, this dependence is greatly reduced since it can be found almost anywhere. This makes global battery production easier and the market less vulnerable to crises or supply issues. Moreover, using sodium in batteries can significantly reduce the pressure on the lithium market, which is facing growing demand due to the increase in electric vehicle production. With the transition to sodium-ion batteries, we can relieve this pressure, creating a more balanced and sustainable market in the long term. Automakers like Tesla stand to benefit greatly from this shift, especially considering that sodium can be extracted more easily and cheaply. And when we talk about more affordable cars, we're not just thinking about the vehicle's price. With battery costs falling, there's also the potential to lower the cost of other electric car components. This includes everything from the charging system to maintenance, as sodium batteries promise to be more durable and require fewer repairs over time. All of this makes the electric car market even more appealing, both for those already in it and for those considering making the transition. Not to mention that producing these batteries could even encourage new industries to emerge in areas where sodium is more abundant. This could create new job opportunities and spur economic development in various parts of the world. And that's a consequence we don't often think about, right? But it's a real possibility. The popularization of these batteries has the potential to transform not just the automotive sector, but also many local economies around the globe. One of the biggest challenges sodium-ion batteries face today is energy density. Basically, they can't store as much energy as lithium-ion batteries. This means that with sodium batteries, you'd have shorter range, requiring more frequent recharges. For those used to lithium batteries that offer long distances per charge, this limitation could be a downside. It's like having to stop more often to refuel on a long trip, only in this case to recharge the car. And it's not just an energy density where sodium batteries lag behind. Their lifespan, or how many charge and discharge cycles they can endure before starting to degrade, is still not as good as lithium batteries. This means that, in some cases, these batteries might have a shorter durability, leading to more frequent replacements. This is, of course, a challenge researchers are working to solve, but it's something to consider, especially when talking about technologies that aim to become the standard in the future. Despite these challenges, it's impossible to ignore the potential of sodium batteries. They are much cheaper to produce, which is already a plus when considering the accessibility of electric vehicles. And since sodium is abundant in many parts of the world, there's no concern about resource shortages or the high mining costs, which are real problems in the case of lithium. This also means that the environmental impact of sodium batteries is considerably lower, as sodium extraction is simpler and less harmful. And you know what else is interesting? Sodium-ion batteries are easier to recycle. Since lithium is a more complicated material to reuse, disposing of lithium-ion batteries becomes an environmental issue. Sodium, being less toxic and more accessible, allows for a more efficient recycling cycle, which makes the sustainability process much more planet-friendly. So, even though sodium batteries aren't as powerful yet, they make up for it in terms of environmental impact. Another positive aspect is safety. Sodium batteries don't tend to overheat or catch fire like lithium batteries can in some cases. This provides greater peace of mind for users, as there's less risk of accidents or issues with battery storage. Imagine an electric car that's not only cheaper, but also has a lower chance of dangerous failures. This could make a big difference in convincing more people to adopt electric car technology. Of course, for all of this to become a large-scale reality, there's still a way to go. Sodium battery technology is advancing, but it still needs to improve in terms of energy density and durability to compete equally with lithium batteries. However, their potential is so great that many already believe that in the not-too-distant future, we will see more cars running on sodium batteries. This won't only reduce vehicle costs, but will also contribute to a more sustainable world. And here lies the great challenge and, at the same time, the great promise. Finding a balance between technological advances and market needs. While sodium batteries offer a more affordable and sustainable alternative, they still need to overcome some technological barriers before becoming the dominant option. But one thing is certain. The future of batteries is changing, and sodium may be a key piece in this transformation. It's curious to think that sodium-ion batteries, which are now gaining so much attention, actually emerged in the 1970s. Who would have thought that this technology, which stayed in the shadow of lithium-ion batteries for so long, would only begin to truly shine decades later? In the early days, sodium-ion batteries were seen as promising, but technological limitations prevented their large-scale use. At the time, their energy density was too low, and they simply couldn't compete with lithium-ion batteries, which quickly dominated the market. But now, with all the advances we're seeing, this story is starting to change in interesting ways. Today, the potential of these batteries is clearer than ever. And the big shift came thanks to advances in materials and design. It's no longer just about making a battery that works. It's about making a battery that's efficient, durable, and sustainable. These new electrode materials, such as iron and manganese compounds, have helped raise the efficiency of these batteries to a much more competitive level. What was once seen as a limitation is now becoming an advantage because sodium, besides being abundant and cheap, could offer a real solution for the energy future. In hindsight, time seems to have been an ally here. If these batteries had been widely implemented in the 1970s with the technology we had back then, we might not be as excited about their potential today. But with the development of new materials and manufacturing techniques over the decades, we are seeing that sodium-ion batteries have much more to offer. They have the power to transform the electric vehicle market, offering a cheaper and more sustainable alternative, especially when considering the growing demand for energy solutions that are less dependent on rare and expensive materials like lithium. Looking to the future, it's clear that sodium-ion batteries could play a crucial role in the transition to a low-carbon economy. With ongoing advancements, we can imagine a scenario where these batteries not only power electric vehicles, but also large-scale energy storage systems, like those needed to integrate renewable energy sources, such as solar and wind, into the power grid. This could revolutionize the energy sector as a whole, as having an accessible and efficient storage solution is one of the biggest challenges we face today. But of course, there are still obstacles to overcome. Sodium-ion batteries have not yet reached the same energy density as lithium-ion batteries, which means they store less energy for the same size. This can be a problem for electric cars, where space and weight are critical factors. However, with the rapid pace of innovations, especially in the field of electrode materials and electrolytes, this issue may be resolved sooner than we think. Even with this limitation, the lower cost and sustainability of these batteries could offset this difference, making them a viable option for many applications. Another interesting point is that sodium-ion batteries can be manufactured using existing infrastructures. This means that factories currently producing lithium-ion batteries can be adapted to produce these new batteries without significant changes. This is a major advantage, as it avoids huge transition costs for companies and accelerates the adoption of this technology. When companies realize they can save money while also offering a sustainable product, this transition becomes even more attractive. The electric vehicle market is becoming increasingly competitive, and the introduction of a more affordable and efficient battery could be a game changer. Automakers that can integrate this technology into their most popular models, such as Tesla cars or even more affordable vehicles, will have a considerable advantage. This is because, in addition to reducing costs, they can also attract environmentally conscious consumers. It's a powerful combination of factors that could shape the future of electric mobility. Just imagine, in the not-too-distant future, stepping into an electric car powered by a sodium-ion battery, knowing that it's not only cheaper, but also more environmentally friendly. It would be a significant step in the right direction, both for the automotive industry and for the planet. And this is only becoming possible now, decades after these batteries were created, thanks to this never-ending technological race. The most interesting thing about all this is that we are just beginning to see what sodium-ion batteries can really do. The possibilities are enormous, and with ongoing advancements, they could become one of the key pieces in the energy revolution that the world desperately needs. And over time, who knows? Maybe these batteries will become the primary energy source for many technologies we can't even imagine yet. Technological advancements in sodium-ion batteries are making headlines, especially with new discoveries in electrode materials. What once seemed like a limited technology with lower capacity compared to lithium-ion batteries is now gaining traction with the inclusion of compounds like iron, manganese, and hard carbon. These materials, which previously didn't receive much attention, are beginning to change the game. They enhance energy storage capacity and overall efficiency, making them a much more viable alternative for electric cars. It may sound complicated, but the idea is simple. These new compounds are helping batteries store more energy and operate more efficiently. Iron, for example, is a relatively inexpensive and abundant material. When used in the electrodes of sodium-ion batteries, it improves the ability to charge and discharge energy more quickly and stably. This is crucial for electric cars, as no one wants to be stuck at a charging station for hours on end. Moreover, iron is also more sustainable in terms of extraction and processing, which aligns perfectly with the goal of reducing the environmental impact of battery production. Another material gaining prominence is manganese. This metal has a high capacity for storing sodium ions, which means batteries can offer greater energy density than before. This is one of the significant limitations of sodium-ion batteries that is gradually being overcome. Manganese also helps improve battery lifespan, which is essential to ensure they can be used for many years without the need for frequent replacements. For those considering buying an electric car in the future, these innovations make the idea much more appealing. Now, hard carbon is a component that seems to have come straight out of science fiction, but it plays a crucial role. It acts as a kind of framework that facilitates the movement of sodium ions within the battery. Imagine that the ions need a road to travel between the anode and cathode, and hard carbon is like the asphalt of that road. With it, the charging and discharging process of the batteries becomes much more efficient. This may not seem like a big deal, but in practical terms, it means that the batteries charge faster and last longer. These innovations are also helping to address one of the biggest challenges of sodium-ion batteries: their life cycle. Since these batteries tend to degrade more quickly than lithium-ion ones, increasing their durability is a crucial step. With the use of these new materials, the batteries are becoming more resilient, meaning they can undergo more charge and discharge cycles before they start to lose efficiency. This is a significant advantage because no one wants to spend money replacing a battery every few years, right? These advancements are also impacting sustainability. Since materials like iron and manganese are much more accessible and less harmful to the environment, the production of these batteries becomes significantly more sustainable. This aligns with the quest for technologies that are not only efficient but also respectful of the planet. The idea of electric cars is already associated with reducing carbon emissions, so it's natural that the batteries follow the same logic, being produced more consciously and with materials that do not deplete natural resources as much. Additionally, one thing that many people don't talk about is the impact these innovations can have on battery costs. With cheaper and more abundant materials, the production costs of these batteries could drop dramatically, which will eventually be reflected in the final price of electric cars. This means that in the future, these vehicles could become much more accessible to the general public. And let's be honest, everyone wants a car that is cheaper, efficient, and sustainable, right? What's most fascinating about all this is seeing how these advancements are developing so rapidly. Just a few years ago, sodium-ion batteries were viewed with skepticism, but now we are beginning to see the real potential of this technology. With these innovations in electrode materials, we are getting closer to a future where these batteries can genuinely compete with lithium-ion ones in terms of performance, but with the advantage of being cheaper and more sustainable. Finally, Tesla has always been a pioneer when it comes to innovation in the electric vehicle sector. And now, with the emergence of sodium batteries, the company may have a brilliant new opportunity in its hands. Imagine a world where Tesla no longer needs to rely so heavily on lithium, a resource that, despite its value, presents various challenges in extraction and cost. By adopting these new batteries, which are cheaper to produce and much more sustainable, Tesla can continue to offer affordable vehicles without raising prices. This means that instead of worrying about lithium scarcity, the company can focus its efforts on innovation and creating even more appealing products for consumers. Additionally, by adopting sodium batteries, Tesla can ensure the continuity of tax credits, as mentioned earlier, which are a great help for those considering purchasing an electric car. These tax incentives make Tesla models much more accessible, attracting an even larger audience. With less reliance on rare and expensive materials like lithium, the company can maintain competitive pricing, especially for models that cater to a more budget-friendly market. This could be a game changer, as more people would have the chance to experience electric mobility without breaking the bank. Just imagine how many families could adopt a Tesla if the price were more affordable. Additionally, by adopting sodium batteries, Tesla can ensure the continuity of tax credits, as previously mentioned, which are a great help for those considering buying an electric car. These tax incentives make Tesla models much more accessible, attracting an even larger audience. With less dependence on rare and expensive materials like lithium, the company can maintain competitive pricing, especially for models that cater to a more budget-friendly market. This could be a game changer, as more people would have the chance to experience electric mobility without breaking the bank. Just imagine how many families could adopt a Tesla if the price were more affordable.